So what I have done is I have created some notes for you people for whatever we have discussed so far. I'll just go through it once so you will know how to read it or what's there in this. So as you can see, polynomials, I have written that we represent it like P of X. Degree could be 1, 2, 3, 4 or anything else. If the degree is 1, it will be called linear. Number of zeros will be 1. And it will cross through the x-axis one time at the maximum. We had explained that. So if the degree is 2, quadratic, it will have 2 zeros. It will cross through the x-axis 2 times. 3 times, like that. Okay, so we had talked about this in the previous classes, so you should be clear about this. Then I wrote this for you, value of a polynomial for a given value of x. So if there is any polynomial p of x, like 3x minus 12, for example, then you can find the value of this polynomial for any value of x, right? So for example, in this case, I have taken x is equal to 2. As you can see here, I have taken x is equal to 2. So the value of this polynomial at x is equal to 2 is represented like p of 2. This is how you read it, p of 2. And then you find out to be minus 6. P of 2 is minus 6. You can find the value for this polynomial for any value of x. You can take x equal to 0, x equal to 100, whatever you want, you can put. But there will be some value. For example, if you put x equal to 4, as you can see on the right hand side here, this side, if you put x equal to 4, then the polynomial becomes 0. So this is a special number, right? 4, by putting 4, it makes the polynomial 0. That is why 4 will become the 0 of this polynomial. Okay. So I took another example. It's a quadratic polynomial. Again, I found p of 1. This turns out to be 0. So for this polynomial also, 1 is the 0 of this polynomial. But we can find the value of this polynomial for any other value of x also. There it will not be 0. It will be something else. So those are not special number. 1 is a very special number. It makes the polynomial 0. That is why this polynomial has a 0, 1. But it is quadratic, so it will have one more 0. There will be one more value of x, which will make this polynomial 0. Okay. So that we will learn how to find it. So we can skip it right now. Okay. So 0 of a polynomial, I had already explained the value of x, which makes the polynomial 0. So let's say instead of saying some value, I'm in general telling that let it be k. So if I put x equal to k, then the polynomial becomes 0. That is, p of k becomes 0. Then you will say that k is the 0 of the polynomial px. Okay. So we had seen the examples just now. This is another example I have put here. 3 is the 0 of this polynomial. Then we had talked about linear polynomials, quadratic polynomials, and cubic polynomials. This is based on the degree. So what I have put in the red box over here, this is the standard form of this polynomial, linear polynomial. Okay, standard form. Do you people understand what the standard form is? Have you seen this before? Do you people know what standard form means? No? Standard form only means every polynomial will have this kind of form. Every linear polynomial will have a form like ax plus b, where a will be some number and b will be some number, some constant, and x is your variable. Okay, then I'm saying a should not be equal to 0. So, for example, let's say if I'm writing a linear polynomial like 5x minus 3, can you see that this is of the form ax plus b? confirm, all of you? Can you see that? What is the value of A here? What is the value of B? Tell me. 5x or only 5? What should it be? Yes, it should be only 5 because x is already there, x. So the coefficient of x is called A. Coefficient of x here in this example is 5. So A should be 5. Okay, and the constant term is, what should be B value here? Yes, very good. It should be -3. We should take into the consideration the sign also. That becomes the part of the constant AB, okay? Whatever it is. So A is 5 and B is 3, something like that. Then I have just written some notes like polynomial with a degree 1, number of zeros, number of times it crosses the x-axis, and the graph will be a straight line. So these things you already know. I've just put that in the note. You people, I will send this in WhatsApp and you will make note of this in your classwork note. Classwork means not your school, of course, your tuition. Okay, then I have drawn some graphs. So this yellow line which you see here, this is a linear polynomial. And what is that polynomial? That polynomial is P of x. P of x, which is equal to 2x minus 8. So this px, I can represent it on the y-axis. That's why I'm calling it as y is equal to px, okay? X is already one variable, which will be represented on the x-axis, right? So the x value will come on x-axis, and the px value, the p of x value, that will come on y-axis. That's why I'm writing y is equal to px. Okay. When you draw the graph, you know that linear polynomial will always have a graph of straight line. And I also told you that it passes through the x-axis one time. So as you can see, here it is passing through. What is the point over here? What is the coordinate of the point where it is passing through? Tell me. What's the coordinate of this point? Coordinate, guys. X comma y. What is the value here? What is x? What is y at this point here? Yes, very good. It's 4 comma 0. X coordinate is 4 here. So first x coordinate you will write 4. Is it going up or down on the y-axis? No, it's exactly on the x-axis. So on x-axis, y is always 0. That's why this point is 4 comma 0. Okay. Now, when you say that 4 comma 0, it's passing through the x-axis at 4 comma 0. You need to understand this very important point. This value 4 over here, it's not like just some any number. It's a very important number. Try to put the value of x equal to 4 in this polynomial and see what happens. Tell me, what is the value of that polynomial at x is equal to 4? Everybody understands that? When you put x equal to 4, the polynomial becomes 0. So this point where it is passing through the x-axis, the graph itself tells you that 4 is the 0 of this polynomial. 4 is the 0 of this polynomial. Okay, x equal to 4 makes the polynomial 0. So just by looking at the graph, you will be able to tell what are the zeros of a polynomial, right? Will you be able to tell that now? Not confident enough? You want more examples? So let's say I have a graph like this, and there is a line which passes through like this. And I'm saying that this coordinate of this point is Yeah. Can you tell me, this is your polynomial? Let's say I didn't even give you the value of what is the polynomial. Still, you should be able to tell me what is the zero of this polynomial. Can you tell me? Yes, very good. -2 is the zero of this polynomial. Why? Because the coordinate of this point is -2, 0. So the value of x is -2 and the y becomes 0 at this value. That is why -2 is the zero of this polynomial. This polynomial is linear, so let me write that also. Okay. Yeah. Then this is your quadratic polynomial. Standard form is ax square plus bx plus c. So if this is your standard form, yes, Tanushri, audio will be there. In the previous, the one I sent today morning, that also had audio, right? Yes. So all the recordings will have audio, okay? Unless something goes wrong. Let's hope not. Let's hope that it doesn't get something goes wrong. Nothing goes wrong for this class, okay? Let's go ahead with this now. Yeah, so what I was saying that, let's say I have this polynomial, 3x squared minus 5x plus 7. Can you tell me, look at the standard form over here and tell me what is the a value, what is the b value, and what is the c value? What are these actually? A, B, C. These are the coefficients of the x square, x, and the constant term. A is the coefficient of x square, B is the coefficient of x, C is the coefficient of the constant term. A is, what is that? Okay, will it be 3x square? The coefficient will be 3x square. A is the coefficient of x square. And this value is equal to 3 only, okay? B is the coefficient of x. So what is B value? Tell me. Yes. So this is -5. We should keep the sign also into consideration. And C is the constant term, which is 7. Okay. So you understand standard form? Okay, good. Then I have drawn some graphs. So these are all different polynomials. So let's say this is your first example. In this polynomial is passing through the x-axis how many times? 2 times. Yeah, one here and another one here. That is why this polynomial has 2 zeros. Okay. But then in this example, second example, as you can see, this polynomial, this is also quadratic. Remember, this is also U-shaped parabola, right? So this is also some quadratic polynomial only. But because of somehow the coefficients are such that it passes through the x-axis only once. So if it passes only once, then it will have only 1 0, even though it is a quadratic polynomial. Okay. Then look at this third example. This is also a quadratic polynomial again, because it is a U-shaped parabola, right? This is also quadratic. You know that. But it is not touching the x-axis at all. This is not at all touching the x-axis. So that's the reason it doesn't have any zeros, no zeros. Whatever value of x you put, it will the polynomial px, it will never be zero, no matter what value of x you put. That is why it never becomes zero. It never touches the x-axis. Is it clear? Yeah. And the fourth one I have just shown you just because you should know that the parabola can be inverted also, depending on what the coefficients are. So this is just another quadratic polynomial. This has two zeros because it is passing through the x-axis at two different places. Okay. So if anyone has any questions, you'll stop me. Otherwise, I'll keep on going. Okay. Fine. So this is cubic polynomial, and the standard form is ax cubed plus bx squared plus cx plus d. And let's take this example over here and tell me what are the coefficients. Let me rewrite it again. Let's say I'm saying px is equal to 7, so minus 7x cubed plus 5x squared minus x plus root 2. Okay. So in this case, I want you to tell me what are the coefficients. So remember, a will be the coefficient of x cubed, b will be the coefficient of x squared, c will be coefficient of x, and d will be the constant term. Yes, go ahead, tell me what is a value again, Pragati? Yes, minus 7 plus 5, okay. Yes. So this is the standard form of a cubic polynomial. Remember, other than a, other than this a value, all the rest can be zero. It will still be cubic. For example, if I write a polynomial like this, let's say I have a polynomial x is equal to, let's say, x cubed minus 3. Is it cubic polynomial or not? Can you figure that out? It is cubic because it has a power 3. So this is going to be a cubic polynomial only. There should be no doubt about that. Okay. But what are the coefficients here? Tell me, what is A, what is B, C, and D? A is 1, okay, good. Very good. Yes, absolutely right. Okay. Can everyone understand this? Okay. So remember that. Yeah, tell me. Absolutely. Only thing is A will not be 0. Why am I saying A will not be 0? What will happen if A becomes 0? Can anyone make a guess? Yes, the highest degree will change. So if I want to write a cubic polynomial, then if I make A is equal to 0, then it will no longer be cubic, right? That is why we say that if I want to write cubic polynomial, then I should not make a is equal to 0. If I want to write quadratic polynomial, don't write the coefficient of x square to be 0. Other things you can make it 0, no problem. Okay, fine. And what we should do now, we'll take up some examples and we'll directly try to solve the first exercise now. Yeah, go ahead, tell me. Yeah, I will send it. Okay, so this is your NCRT book, and after the basics, this is the topic which you will be studying: geometric meaning of zeros of polynomial. What does it mean to be zero of a polynomial? So that just now we saw in our because the book, NCRT book. Okay, that's good. So whenever we are going through the class, make sure whoever has the book, keep your book open with you. And if you want to put some quick notes, whatever, when I'm saying something, you can make a note in the book itself with the pencil, of course. Okay, so look at this example, what they have given you in NCRT book. Yeah. So for example, they have given you y is equal to 2x plus 3. Okay. 2x plus 3. So if you want to draw the graph of this one, you can find the zero of this polynomial graphically also. Using the graph, you can find the zero of this polynomial. How to do that? Let's see. So let's start the next page. So first of all, it's given y is equal to 2x plus 3. If you want to draw a graph, what do you have to do as a first step? First step, you have to draw the table in which you'll have a place for x and the place for y. And since you know that this is a linear polynomial, right? Everybody knows that it's a linear polynomial. Quickly give me a confirmation. Yes. Everybody knows that it is linear means the graph is going to be a straight line. So if something is a straight line, having 2 points is more than enough to draw a straight line, correct? That is why I will just make space for 2 points only. 1 point here, another point here. Now let's put some values of x. Let's take the same values which they have taken here so that there is no confusion. So let's say when I put x equal to minus 2, when I put x equal to minus 2, find the value of y. What will be y? For x equal to minus 2, y will be 2 times of minus 2 plus 3. Is that right? Everybody got that minus 1? And everyone got the steps also. You put x equal to minus 2 into this polynomial. In place of x, you put minus 2. There is 2, you leave it as it is. 3, you leave as it is. In place of x, you have just put minus 2. Everybody understands this. Just give me a confirmation, guys. And what you can do, you can take some other value of x. Let's say if I put x equal to 2, value of y for that? Yes, of course. So when you put x equal to 2, y becomes 7. Now I have got 2 points. What are the 2 points? -2 comma -1. First point is -2 comma -1. This is the coordinate of the first point. And the coordinate of the second point is, tell me what is the coordinate of second point? Yes. Now you have got 2 points. It's very easy to draw a graph. So I'm not going to put all those lines over here. Just look at the graph in this book itself. As you can see, the first point they have taken as -2 comma -1. Where is it? Okay, I think they have drawn it. Problem with this graph. Okay. So when x is -2, y should have been. Oh, okay, it's correct only. No, it's over here. The point is here. I'm sorry. -2 comma -1. That point is over here. Okay, everyone can see that. Sorry about that. I thought they made a mistake. I was looking for the point here. It is -1, right? So it will be over here, of course. -2 comma -1. And where is the other point? 2 comma 7. So there's 2 here and 7 here. So this is your second point. Okay. Take the 2 points, join them, you will get a straight line. And which axis you should look at for finding the 0? X-axis or y-axis? Yes, we are looking at x-axis because this polynomial is in which variable? The polynomial is in variable x, p of x, correct? That is why we look at the x-axis. So at x-axis, it is passing through at this point over here. And what is the coordinate? They have mentioned that it's -3/2. So if it is -3/2, then what is the 0 of this polynomial? Of course, the 0 of this polynomial is -3/2. Everybody agrees with this? Right. So if we have a linear polynomial, finding the 0 of linear polynomial is very easy. Let's do that. So as I'll explain what this means. Okay. So first of all, let's take a linear. One of you, anyone tell me what is the standard form of linear polynomial? Ax plus b, absolutely right. Now, if you want to find the 0 of this polynomial, if you want to find out the 0, what would you do? You'll make the polynomial. One of the ways to find the 0 is, one way was what? We can keep on trying some values. I can put x equal to 0, x equal to 1, x equal to so on up to infinity, and backside also x equal to -1. Even some fraction values we will have to try. So trying something and then checking whether the px value becomes 0 or not, that is one of the ways to find the zeros. But as you can understand, is it a very nice way? Trying all the numbers and then seeing whether it becomes 0 or not? Is it a very good way to find the 0 of polynomial? No, right? So this method is basically called trial and error method. Okay, you would have learned this in your earlier classes. Trial and error method, trying some values and finding whether the polynomial becomes 0 or not. So of course that's not a very good idea. So we are not going to use it in 10 standard. We are going to use different approach. This also you know already. So if you want to find out what is the 0 of a polynomial, you already make it 0, make it equal to 0. Now you get an equation and you know how to solve an equation. It's a simple linear equation. All of you solve this and tell me what will be the value of x, which will make it 0. What should I write? Minus of b by a. So if some of you are getting confused by what is this a and b, sir is telling it's a simple equation, but there are some a and b over there. So don't get confused by that. Instead of a, you could have a 3 over there. So 3x, and instead of b, you could have, let's say, plus 5. So 3 plus 5 is equal to 0. What would you do? You will take 3x as it is. You'll transpose the 5 to the other side. So you'll get 3x is equal to minus 5. And then you will transpose 3 to the denominator of this side. So it will become minus 5 by 3. Correct? This is how you will find the x value, no? If it was a simple equation like this. Same thing we are doing here also. We have not done anything different. B is here, transpose to the other side. So ax will be minus b. Then you leave x here itself and transpose a to the other side. Then it will become x equal to minus b by a. So this is the standard form. For whatever value of a or b you put, the value of x will always be minus b by a. So you don't even have to go through all the calculation. If you knew this formula, you could have just put that over here, and you would have said x is equal to minus b by a. So minus b, what is the b value here? It is 5, and a value is 3. So minus 5 by 3, you can directly write it instead of going through the calculation. Is it clear? Okay, now some of you might be thinking, why is sir going through so much trouble finding the formula when it's so easy to find the value? I can just transpose and get this. Why do we need a formula? If you thought about this, then you are on the right approach. If you didn't think about this, then you people are sleeping. So to answer that, my question only, why am I finding the this formula? Because it's for a linear polynomial, it's very simple. We can use, instead of going through the formula, we can just do the transpose and find the value minus 5 by 3. But this very similar idea works for higher degree polynomial also. So this minus b by a will come in handy for higher degree polynomials, for a quadratic or a cubic. It has some meaning. This minus b by a has some meaning, and we will learn about that. Okay, now getting to the topic which I have written here at the top. Relation between coefficients and zeros of a polynomial. So if something is a linear polynomial, how many zeros it will have maximum? Yes, it will have a maximum of 1 0 only. And that 0 we can very easily find by making it equal to 0, and that 0 will be minus b by a. So the 0 of a linear polynomial will always be minus of b by a. A and b are the coefficients, and I'm saying that minus b by a will become the 0. So is this not a relation between 0 and coefficients? It is, okay. So it's the relation between the coefficients and the zero of linear polynomial. But linear is always very easy. You have been studying this from your 7th or 8th standard probably. Of course, quadratic and cubic are not going to be so simple because they have more than one zero. Right? So fine. So we are done with today's class. We will look at the quadratic polynomial tomorrow. So how the coefficients of a quadratic polynomial are related to the zeros of that polynomial. We will see that relation tomorrow. So as of now, we're done for the class. Okay, so you take a break for 10 minutes. Don't look at the screen. What is the time now? 6:10, right? Yeah. So I'll start the